Okay, so here's the problem. The arch of a bridge is semi-elliptical. The base of the arch is 50 feet across, and the highest part is 40 feet high. Find the equation of an ellipse, and find the height of the arch 5 feet from the center of the bridge. So the general form of the equation of an ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1, where h comma k is equal to the center, and the vertices are, for a horizontal ellipse like that, these 2 points are the vertices. Here's the center. And the vertices are at h plus or minus a, comma, k. Now for a vertical ellipse like this, your vertices are at the top and bottom, as your center here, and that would be h, comma, k plus or minus b, like so. Well, this is what we know about ellipses in general. So we'll move that down and keep our main formula visible. So we have this problem here. So let's draw a diagram of what's going on here. So here's my graph, and this would be y, this is x, and of course this is not to scale. This is 40. This would be my ellipse, like so. And this distance, of course, is 50. Well, from this we know we can center the ellipse anywhere we'd like on our coordinate plane. So for simplicity's sake, it's easiest to center it at the origin. So h, comma, k would be equal to 0, comma, 0. That way, we're dealing with fewer numeric terms. However, we could center this ellipse anywhere we want. So if it's centered at 0, 0, then we know that this is 25, positive, and this is negative 25 over here, because it's 50 feet across. And we know that this distance here is a, because this is the vertice, and h plus a is equal to one of the vertices, which here it's at 25. If h is 0, 25, therefore a is 25. So this is a, and b. Well, we know that a is equal to 25, and b is obviously equal to 40, because if this distance is b, we have 40 up here. So we now have our equation for the ellipse. X squared over 25 squared plus y squared over 40 squared is equal to 1. So that was pretty simple. This is our equation for the ellipse. Now, let's say we wanted to do part B, which involves finding the height of the arch 5 feet from the center of the bridge. I'm going to redraw this diagram here. So we have, and I'm going to exaggerate this arch, like so. Now, we know this is 40, up here. This is 25. This is our origin. And we want to know 5 feet from the center of the bridge. So at this point, x is equal to 5. What is this distance here? Well, it's obviously a little bit less than 40 because a true ellipse, this is its highest point and it starts to go back down. So how do we find this distance? We'll call this y because vertical distances are often labeled y. Now, we come back to our equation that we found and we realize that we have we only are missing 2 variables in this equation, and we have a variable here of x. So we can just plug in to our equation because we know x is equal to 5 at this point. This is the point we're trying to find where it's 5 comma y. Okay, so x is equal to 5. 5 squared over 25 squared plus y squared over 40 squared is equal to 1. Well, this cancels out one of those exponents because this is not an x, but it canceled too, because 25 over 25 squared is 1 over 25. So we have y squared over 40 squared is equal to 24 25ths. Then we can bring over the 40. 24 is 40 squared over 25. And then we get y is equal to the square root. 24 times 40 squared over 25. And of course, you'd simplify that out, but that is the height of the bridge at that point.